So, Dr. Mack, we've pretty much reached now.
Yes.
In the cosmic timeline, right?
Yeah, we got into life.
Right. And the universe now is, just tell me this, whether it's true or not, stable-ish.
You said ish at the end of that, right?
I did.
Yeah. Then totally.
We've reached the present in our journey through the history of the entire universe, but before we continue moving forward in our timeline, I have a few big questions that I haven't had a chance to ask Dr. Mack yet, so we're going to try to get those answered today. One of the things I wanted to talk about today was a timeline of our understanding of this stuff. It's something that's come up in some of the initial conversations from our listeners, some of the feedback that we've been hearing. And by the way, thank you all for your kind comments and wonderful questions. It's been awesome to see the response to the pod. But this is all quite new. This is one of the things I've learned about cosmology is that you've got to zoom in and out on time scales so much. We could say things are going to be pretty stable for the next billion years on the galactic scale, but definitely not on the solar system scale and definitely not on the human scale, right? We've only been around for 250,000 years. If we make it to the point where the sun is a problem, what a success that would be.
Right. Yeah, totally. Yeah.
I would be thrilled if our biggest threat is solar.
Right.
Because that would mean that we made it for tens or hundreds of millions of years from now.
Yeah.
I've been reading and writing a lot about infectious disease over the last 5 years. So my timeline for how we understand and think about the stars and our relationship to them really begins in what some historians have called the calamitous 14th century, when there was the Black Death that eliminated about half of all people living in Northern Africa, Asia, and Europe. And also alongside that, all this kind of conflict. And it's really interesting to read the primary sources about this because they all universally say, well, we all kind of knew this was going to happen because of the eclipses. We all sort of knew that there was going to be some massive collapse because we had 2 eclipses recently. And so for a long time, people have been connecting human history and the human story to the stars. And I wonder how you think about that. I wonder how you think about the kind of the journey that we had to go on from, reverse causation of, we have to go, which is how I think of it. We have to find an excuse for why the Black Death happened, and we have to look to the stars. And so there has to be a reason in the stars because that's how astrology works, to where we are now, where we try to focus on, understanding cause and effect in the universe very differently.
Yeah, well.
Or maybe we don't.
I mean, people do still want to find causes outside of human nature or outside of chance, right? People do still want explanations. I mean, in the scientific community, we have sort of standards of evidence and we evaluate causes and we try and make scientific connections between things that are valid and testable and have methodology and all of that kind of thing, right? But humans just in their lives outside of science still do yearn for causes and reasons, right? That's human nature.
Right.
And I think that's part of why things like astrology have persisted, is that people want to have something external to say, well, that's why this happened, or that's why I'm the way I am, or, this puts me into some context that feels big and meaningful to me. I think that's where that yearning comes from. But, as scientists, we have to approach things differently in terms of we have all these sort of conventions around what constitutes evidence, what constitutes, strong evidence, or you might call it proof, although we're pretty careful about that word, and how we think through, what are the possible connections, and then how do we test that scenario, and how do we evaluate that against other scenarios. That's been part of the scientific method, part of the way that scientists evaluate evidence since the beginning of science. And so, when something like astrology comes up against that, it fails, right? Like it doesn't work in a number of ways.
Yeah, I've often thought that I would be more interested in astrology if I were more of a Virgo. But I am a Virgo by birth, but when I read about Virgos, I'm like, there's just nothing there for me. And if there were, I probably would be like, oh yeah, that totally makes sense. Like this all falls into line for me because I'm susceptible to that same human nature. But like, as it happens, I just have no connection to being a Virgo whatsoever. And when people describe Virgos, I'm like, that sounds lovely. I wish I were like that, but I'm not. I'm not like that at all.
A lot of times when people talk about astrology and astronomy, people bring up that, a lot of the early astronomers were studying the stars and stuff sort of in the context of astrology, sort of in the context of like trying to find meanings around things that happen on Earth and connecting things like, the eclipses, or people used to think that there were certain alignments of celestial objects that were good luck or fortuitous, or people would want advice, leaders would want advice about doing things based on astrology as a way to like read the intentions of the gods or whatever. And it is true that there were a lot of people who in early studies of astronomy were charting the stars for reasons having to do with sort of human behavior, like, and trying to make connections with human behavior. But I don't think that necessarily means that there's anything deep about astrology as a phenomenon. I think it's just like, that's just always how people try and do stuff. They try to find patterns and connections. And like, that's the human nature part. The science part is about, learning about the forces and the evolution of the cosmos and all of this kind of stuff, and using evidence and testing hypotheses. And so like the study of a lot of different things in science kind of started out with trying to connect it to human concepts, chemistry and the humors and all this stuff with like alchemy, right? And that started with something that is not scientific really, but at the time that was part of why they were doing all these experiments with metals and trying to figure out how to make gold or make different kinds of potions that would be useful for people. I think a lot of those early experiments in science were built around people trying to understand not just the world around them, but how they fit into it, how human events and feelings and human nature connect to this larger world. And that's just a constant of human nature. Like, we want to find meaning, we want to connect ourselves, we want to feel important, and we want to know why we're here and how it all fits together. Right. And so at various times in history, we've always been kind of branching out, trying to find those connections. And I think that's remains part of human nature. People still do want to find those connections and find that purpose, that meaning. Like, what does it mean for me? Why am I here? How do I fit into the grand scheme of things?
Yeah, I mean, we certainly are in the business of trying to make meaning, but we're also in the business of trying to derive meaning. And that tension between the meaning we create and the meaning we derive through understanding or through some relationship with a whether it's a god or a structure of meaning like astrology. I'm fascinated by the ways that we are both making meaning and trying to derive meaning at the same time, and how science fits into that, because science is trying to derive truth from information, is trying to, process observation into and evidence into understanding, which is a way of making meaning, I think.
Yeah. And I think that one of the things that I find really interesting is this discussion about, like, is the purpose of science to find truth? Is it to find the ultimate reality? And is that a thing that is possible to do, right? And I think that in physics especially, I mean, I don't know, probably in all sciences, what we're really doing, like, on a day-to-day basis, like the actual work of it, is to make mathematical models of the universe or of whatever we're observing that match the observations, right? So you have a number of observations, you get data from those observations, and you try and build some kind of mathematical black box where if you put that data in, you get the right data out, or vice versa. Like you put in the initial parameters of the experiment into this mathematical black box, and you get out the data that you actually saw in the experiment, right? And so it's all about creating a mathematical, cartoon of the world, essentially, of whatever system you're trying to model. You're creating this mathematical version of it, like a bunch of stick figures that do the right things, that connect in the right way to match the data that you see. And the process of science is just constantly refining those mathematical cartoons to more closely approximate all the data you're getting. And then when you get different kinds of data, you take that cartoon and you see if you get the right data with that cartoon in this new context. And if you don't, then you have to, alter that cartoon or change it in some way to fit that broader context where you have these other experiments. And so that's just constantly what we're doing in science is creating these more and more sort of detailed or sophisticated or more applicable mathematical cartoons. And the kind of point of it, I guess, is to make some that are useful, where you can take an experiment you've never done before and predict what the results are going to be. And so that you can sort of expand on your ability to work with the world, to work with the universe in some way, and have, sort of a more coherent picture of what's happening. But I think ever assuming that cartoon is like the reality gets quite tricky, right? And because we're never going to have complete data. There are reasons that we think are physically sort of built into the universe that prevent us from getting complete data about the universe. And so, I think the hope is that our models are getting closer and closer to whatever reality actually is, but in practice, that's kind of impossible to test, right? So as scientists, we can't really say if our science is approximating reality or not. You see what I mean?
Yeah, it's almost like, and correct me if I'm wrong in this analogy here, but it almost seems like generations of video games where you start off with Donkey Kong, who doesn't look very much like a donkey, and then you have Super Mario Brothers, and that looks a little bit more like Plumber. And then you have Red Dead Redemption 2, and that looks quite a lot like a cowboy, but it's not a cowboy. And it kind of can't be.
Right. And like if the only way you could tell how close you are to having a cowboy is to interact with the video game and see what it does, right? Like we don't
right.
Like we don't have something and some external way to
we don't have a cowboy to judge cowboys against.
Yeah, exactly. And so we're just constantly kind of iterating, and we're getting more data, more expansive data, as though sort of the map of the universe in your video game is getting bigger, but or your resolution is increasing or something like that, but we can't be outside of the universe comparing the universe to our model. We're in the model. We're in the universe, we're making the model, we're inside of it, and we're poking out and looking through little peepholes and saying does this match? But we're always kind of constrained by the observations we can make, the experiments we can do. Essentially, we're trying to say we have one mathematical cartoon and we have another mathematical cartoon, and we compare them both against the data, and whichever one fits the data better, we say that's probably more like what reality actually is. Right. But it's always some kind of approximation.
This is another question we've gotten a lot. Do you think the purpose of science is to be useful or is to understand? Does it have to be useful? There's part of me that thinks it's enough to just understand. It's beautiful to just seek understanding. It doesn't have to have real-world applications for GPS or whatever.
Yeah, I think that, when useful to a physicist is different than useful to a regular person.
Fair enough.
So when I talk about we prefer models that are useful, what I mean by useful is it allows us to make predictions about another kind of experiment or another kind of observation that expands our understanding. But ultimately, Yeah, we're just trying to understand. And there are always applications at some point to some things that we do. I mean, some things might never have applications, right? But in general, we expect that there are some connections to like real world stuff. It's a funny term, right? Real world, when we're just talking about the universe and ultimate reality.
The actual universe, the realist world.
Yeah. But this is something that comes up a lot with theoretical physics. So last week, I was involved in a program called Science Meets Parliament, where I went to Ottawa to talk to members of parliament about science. I was part of a big group of people and a bunch of scientists, and we went and talked to our members of parliament and like showed up and interacted. And the idea was to kind of make more connections between scientists and the lawmakers and kind of, just sort of build those relationships, right? And one of the things that we practiced or talked about beforehand was like, what is your pitch for, like, how do you talk about your science? If you only have like 3 minutes with an MP, like, how would you explain what you do? And there was a lot of talk about like, what's the real world implication? Like, what is the output of this? And how does this affect people's lives? And I'm a theoretical cosmologist. Like that's a hard ask, right, for me. Like, I was trying to kind of express like, nothing I do in my work is going to make your car run faster in the next 10 years, right? Like that's just not something that's going to happen. In theoretical physics, it is true that there's a kind of like historical pattern that advances in theoretical physics lead to new and very, very useful technologies down the road, decades, maybe centuries later, right? I mean, you look at one of the standard examples is GPS, right? So Einstein came up with general relativity in the early 1900s. And now if we didn't include the time dilation due to the motion of these satellites and also their distance from the center of the Earth, then, you would lose something like 10 kilometers a day of accuracy on your GPS systems, right? Like, it would be real bad. Like, we really need that. Einstein could not have predicted that was going to be an outcome of the equations he was writing down. And there have been a bunch of examples of that around quantum mechanics, around, even just electricity, subatomic physics. The discovery of antimatter, is now, like, people get PET scans, right? That's positron emission tomography, right? So, like, that's antimatter being shot into you for scanning purposes. Like, all of that kind of stuff, like, it comes from basic exploration. And that basic exploration was not done for the purpose of creating medical technology or navigational technology or microelectronics. Like, that exploration was done because people just wanted to understand the universe. And so it's kind of a funny thing because we're doing this work just because we want to know, right? Just because, like, we really want to know. At some level, some of the sort of reasons for our funding is because it probably will lead to technology in the future. And that's something that when we talk about it to people who make decisions about whether or not this is something that society should pay for, that comes up because, if you don't make those investments, you don't get the return on those investments. And blue sky, fundamental research has massive return on investment just historically. And that trend is very likely to continue based on everything we understand about how science works. But, if you wander around a physics department and talk to people, like, they just want to understand the universe, right? Like, we're just trying to figure it out because we want to know. And I think that that's also human nature. Like, we humans like to know stuff. Like, that's part of what makes humans happy is understanding stuff. Like, we are people who enjoy puzzles, right? Like we like, people do Wordle every day and, like, there's no purpose to that. Like,
yeah, and nobody asks, like, what is the purpose of Wordle?
Yeah, exactly.
I have a version of this in my world, which is that I don't write the stuff that I write to make money or ultimately, like, I do write it for an audience, but the reason I'm writing it in the moment is to understand. It is how I have thoughts, and it is how I understand what I think, and, like, how I bring some kind of form or expression to the deeply abstract stuff that's happening inside of me. Otherwise, I don't have a way to bring that up and out and give form to it. And in that sense, there's something quite pure about it, I guess. Like, it's about a human desire to understand and express rather than a desire to, turn that expression into money or technology or whatever. I think that goes all the way back.
Mm-hmm. Oh yeah.
And it's my favorite, or I guess one of my top two favorite things about humans, the other one being collaboration. I love how we work together to figure stuff out. Like, I love watching, even when it's like moving a couch down a staircase, I love watching us figure that out together.
Yeah. And that's something that I love about physics also is how collaborative it is, and how much you see people like around here at the Perimeter Institute. The place is full of chalkboards. Like, we've just got blackboards everywhere. Like there's blackboards in the atrium. There's blackboards, next to the sink. There's blackboards at the outdoor patios. So we don't have blackboards inside the bistro, but we do have little centerpieces that have slips of paper and pencils in the centerpieces so that we can write down our things when we need to write down our equations for each other. There's this constant conversation, and people are always gathered around the blackboards, writing equations, talking about their research. They're at the lunch tables writing, drawing diagrams on the little slips of paper. Like, it's just this constant dialogue, and everybody's always not, people do sit in their offices and do work, but a lot of what you see is people talking to each other, connecting with each other, and saying, like, I have this idea. What do you think of this idea? I have this other idea. How does this idea fit together? And then collaboratively building these different ways of thinking about the universe. And I mean, I think that's just so cool.
And the most beautiful thing about it to me is that it's a collaboration that extends through time and space. Like, yes, it's happening at the Perimeter Institute right now, but you're also collaborating with Einstein, and you're collaborating with, Mayan astronomers from 700 years ago. And that way that we build knowledge together, like when I'm writing, I'm collaborating with writers who are way, way better than me. Like, I'm collaborating with Shakespeare and Toni Morrison, now they're not necessarily collaborating with me, but I'm collaborating with them.
Right. Yeah.
And I love that human knowledge formation, expression, understanding can extend through time and space like that, and can extend even over like the broadest divide of death. That's really lovely and encouraging to me.
Yeah, that is really wonderful. Like, when you're reading a paper from somebody from years ago and you connect with an idea that they've written down, and you finally understand something, it's like they're talking to you and you're part of that process. It's very cool.
Yeah. But I also think, and I know this is where I think you and I are different. I think we're going to disagree about this.
Okay.
And it's refreshing. We don't disagree enough on this podcast. I know that you're hesitant to take science and turn it into like real world beauty, if we're going to use the term real world again.
Okay.
But I find something so beautiful about, for instance, the fact that the protons inside of me can be traced back to the Big Bang, about the fact that, like, I do have that urge to metaphorize, I guess, science into life, into my experience of being alive. And I know that metaphorization is extremely dangerous, and down that road lies much ruin. But I still find myself really astonished and almost in love with the idea that the matter within me goes all the way back, or that, matter cannot be created or destroyed. Like, that's stupidly beautiful to me.
I mean, matter can be turned into something, to energy, and vice versa. Like, it can be turned into other kinds of matter.
Right. But it can't, but like, it's all been there.
You can't get rid of, like, there's some degree in which energy conservation is pretty solid, right? In certain contexts.
Right. Oh, you're gonna ruin my whole conservation of energy beauty.
No.
You're gonna be like, well, I mean, it's
fine.
Conserved, but not the way you think it's conserved.
I feel a need to be precise about that.
I know. I appreciate that.
No, but I don't disagree with you that this stuff can be beautiful. I mean, like, look, I am also susceptible to the beauty of the cosmic creation, right? Like, I've written poetry about it. Like, I'm not like. Like, I'm not entirely unconnected to the idea that there is something profoundly beautiful about being part of the universe. I guess the part that I'm not sure about is like when that beauty is turned into meaning. I think that that's complicated, right?
That like we can know, for instance, that like life is meaningful, like or that like our souls will somehow be preserved because energy is never destroyed, kind of thing. Like when it gets into that territory, that's when you get nervous.
Right, exactly. I think that you know, we have to kind of create our own meaning in this universe because I don't think it gives it to us for free.
Right.
But I think that connecting our meaning, our human purpose to cosmic events or, you know, the nature of the universe, I think that gets complicated because you can end up in sort of weird places with that. And so I think it's great to see that beauty. I think the beauty is real. And I think that we need to find ways to construct meaning, but I think that we also need to be aware that we are constructing it.
Right.
Right, that it's not intrinsic to the universe.
Yes, this reminds me of one of my favorite observations by my late great friend Amy Cross Rosenthal. She wrote about this, but we also had a conversation about it once where I was like, you just find so much meaning in coincidence, and of course it's just coincidence. Like it just happens. One out of a million things happen all the time because there are lots of things that can happen. And she was like, yeah, no, I know. I just still like it. I just still find it beautiful. I still find it meaningful. And if you can understand that you're constructing meaning and still find meaning, to me, that's the ultimate, that's like you've cracked the code.
Right.
If you can still feel the meaning as really real while also understanding that it's made, that it's constructed. Because lots of things that are constructed are really real. Like I'm talking to you through a computer that's constructed and really real. Like it's just a different kind of really real.
Like I've always admired like people who can play a musical instrument and they can bring themselves joy through like the movement of their hands on the piano keys, or people who can sing to themselves and enjoy the sound of their their own voice. I mean, that's like you're creating something for yourself to enjoy that's entirely contained within you. I think that is a lovely thing to be able to do. And if you can do that with thinking about the way you fit into the cosmos and the beauty of that and have that be meaning in and of itself, I think that's great.
So even if meaning is constructed, it's still real. There's beauty in how we fit into the cosmos and how we fit together, even if that beauty is constructed by us. And I find such consolation and encouragement in that. It reminds me that we are part of a great human web of meaning-making, and each of us is contributing to it by making meaning and beauty within ourselves and in collaboration with others. And even after you die, the ways you constructed meaning and the people you constructed it with will go on being shaped by your meaning-making. And there's comfort there too. But, of course, you can also help your loved ones in very practical ways after death, like through, you guessed it, life insurance. You need life insurance, and Policy Genius is here to help. With Policy Genius, you can find life insurance policies that start at just $292 per year for $1 million of coverage. Some options offer same-day approval and avoid unnecessary medical exams, and Policy Genius makes it easy with a licensed support team that advocates for you throughout the process, which is why they have so many 5-star reviews from Google and Trustpilot. Don't put off life insurance. Make it easy with Policy Genius. Head to policygenius.com/crash course or click the link in the description to get your free life insurance quotes and see how much you could save. That's policygenius.com/crash course. Policy Genius. Because meaning may be constructed, but life insurance is for real. This podcast has caused me a real problem. I'm just going to lay out for you what my problem is, and then you can poke holes in it, because I'm sure that there are holes in it.
Okay.
The universe came into being. We don't know what the spark was. Maybe there was a spark, whatever. Mm-hmm. And then it seems like everything that happened after that had to happen the way that it happened. It seems like there were reasons why the Higgs field happened. It seems like there are reasons why protons formed. It seems like there are reasons why stars formed. And it seems like all of that stuff was sort of inevitable from the first moment. That, like, it was all pre-written, for lack of a better term. And also it seems like maybe the far future is inevitable on the scale of the universe. It seems like there was always going to be a Milky Way galaxy, like there was always going to be a sun, like there was always going to be an Earth with a moon. And that means that if you drill all the way down, that I was always going to be born on August 24th, 1977, that I was always going to write The Fault in Our Stars, that I was always going to live the exact life that I've lived, that I was always going to meet Sarah in high school but not really know her, and then years later we were going to meet in Chicago and fall in love and get married and have 2 kids. Like, all of that feels suddenly inevitable. And I wonder if you ever think about this stuff in the context of free will, in the context of human choice, and if so, what you think about.
So my first thought does not go to free will or human choice. My first thought goes to chaos and quantum uncertainty.
Okay.
So chaos and quantum uncertainty are different things, but I think they get conflated a lot in discussions like this. So quantum uncertainty is the fact that there's sort of a limit to how well we can measure things on a quantum level. It usually comes up in the context of Heisenberg's uncertainty principle, which is this idea that if you have a particle, you can measure its position to a certain extent, and you can measure its momentum, its velocity, its movement to a certain extent, but you can't know both of them perfectly at the same time. So the better you measure the position, the worse you know it's the speed, and vice versa.
Does this also factor in any way to the weirdness of protons, where sometimes protons have particles in them or that weigh more than a proton weighs?
I mean, that whole thing is just infuriating, as I have said many times before. Sort of. I mean, so that it's connected to the same idea that there is sort of this uncertainty on the quantum level where a particle can't be fully localized, and there's also this phenomenon of superposition where something can be in kind of 2 states at once until you measure it.
Oh boy.
And something can be like in a combination of a couple of different states until you measure it, and that gets into a whole bunch of stuff around like entanglement, and it gets real complicated real fast. But
sounds complicated. I'm already lost.
Yeah, so on a quantum level, like if you do an experiment that's the equivalent of like flipping a quantum coin. So this could be like sending a photon through a beam splitter where it has a 50% chance of going either direction. Until you make the measurement, there's a sense in which it's gone both ways, and there are ways you can experimentally kind of show that it has gone both ways, like that some segment of it is kind of, in some sense, has gone both ways. And then you do the measurement and you see like, oh, it just went that way, right? And so until you do the measurement, it's kind of in both states. This is the quantum uncertainty thing that I was referring to before, that there's an extent to which there is some uncertainty that's just built into how physics works. And so there are things that happened like in the very, very early universe. Like we talked about the process of cosmic inflation, which we don't know for sure happened, but it fits the data. It seems likely something like that happened, where the sort of large-scale structure of the universe, the distribution of matter on the scales of clusters of galaxies, seems like it could be traced back to the movement, the sort of fluctuations in a quantum field in the very, very early universe. And so those fluctuations could have gone a different way, and then we'd have a cluster of galaxies in a different place in the universe, right? Mm-hmm. And that's a real like huge consequence of like a little bit of quantum uncertainty.
Right. Okay.
So there's that sense in which like Did the Milky Way have to form where it did? Well, I mean, there could have been a quantum fluctuation in a different direction, and we wouldn't have a Milky Way here. There'd be, a different size galaxy in a different place in a different sort of supercluster or something like that, right?
Yeah.
So there's that kind of uncertainty. And then chaos is this thing where a small input can cause a really big sort of set of consequences. This is the butterfly flapping its wings causes a hurricane. That effect is this chaos thing where you can have a little change that has big consequences. And so those two things together make me think that, like, although the sort of initial conditions for the universe or the sort of process of the universe is always going to create very similar looking universes, you wouldn't necessarily have you in every universe, right? Like if we did the trial of the universe many times, there'd be changes in the quantum state of the initial conditions. There'd also be little tweaks because of this chaos thing that might also connect to quantum uncertainty if you drill down far enough down. And so, like, you wouldn't be born on the same day. You wouldn't, have exactly the same life necessarily. If you reran the universe again, starting with slightly different, like even the same initial conditions, but with quantum uncertainty built in, you'd have different outcomes, right? And this is like when you do these. I don't know if you've ever seen this experiment where you have like a bunch of marbles and you drop them through like a box with a bunch of pins in it and they all fall down, but they make a little like normal distribution, a Gaussian distribution where like they all kind of pile up mostly in the center, and then you get this
looks like a bell curve.
It's a bell curve. Yes, that's what it is. Yeah. So every time you do that experiment, the balls are going to eventually form a bell curve, but they're going to be slightly different number of balls in every slot at the end, right? Each time you do it.
And we're going to get there a different way. Like the first ball might not end up in the same place.
Exactly. And I feel like that's kind of how I think about the sort of inevitability of the universe that we see today. Like you could rerun the universe and each time you would get the same kind of bell curve, like of the way that things are in the universe. You get statistically it would look the same, but the details might be different.
So is that how you think about free will and human choice in this world?
I don't know.
Or do you not connect it at all to the universe?
I think I'm very resistant to delving too much into free will and human choice just because like
on a science level or on a personal level?
On a personal level. I mean, on a science level, I don't think that my work connects to it. I think that the question of free will and human choice is something to do with philosophers. Maybe you can get into neuroscience, but I don't think it has anything to do with cosmology. So I just don't have the expertise for it. But also on a personal level, like what would I do differently? Like how would that, like I feel like that's just that leads the way to like serious like mental difficulties without a benefit. Like if I determine that there is no free will,
Katie. Well, like that's if I could choose to not have serious mental difficulties without a benefit, I would of course choose that. I didn't realize that was an option. Is that on the table?
I mean, I just like but this is why I don't read about it because I don't want to go there. I don't know. Well,
you don't want to go there.
I don't know. Like if I found out that there, if I convinced myself that there was no free will, that would feel very confining and upsetting. If I convinced myself that there was free will, then that would be terrifying. Like either way, I don't.
Right. I guess the argument in favor of like free will being terrifying is that then every choice that you make has tremendous import.
Yeah.
Right?
Yeah.
Like the choice about whether or not you drive one car or another to school in the morning becomes existential.
And suddenly it's all your fault, right?
Right. And I am resistant to the idea that my life is either my fault or to my credit. Like I'm very resistant to people when they say like, oh, like life is mostly a series of choices, because I've seen too many lives that are clearly not a series of choices.
I mean, I think my personal feeling about it is that, it's always some kind of mix, right? Like we're set up with our initial conditions, and we have a little bit of wiggle room in that, right? Like different people have different sort of origins, different childhoods, different sets of resources, and different sort of setups of their brain and their personality from various things that might have happened to them in various parts of their lives. And then maybe there are ways to work within that and make better or worse choices. But ultimately, like actually figuring out, like teasing out, like, well, you made that choice because you had, you went through this trauma, but you made this choice because you just chose badly. Like those kinds of things. I don't know. I feel like that's that's an impossible thing to tease out and not necessarily useful.
I like the way that you said that like the conditions are set up, but maybe there are some fluctuations that shape the outcome. So maybe it's not that different from the universe.
Right. And whether or not each individual life is necessarily going to like make that same bell curve. I think that like there's always going to be fluctuations. Maybe there's going to be a big fluctuation in one direction, a big fluctuation in the other direction, and on the average, we all kind of look the same in some way. But yeah, I mean, I think that's a reasonable way to think about it. That we're all we have our sort of initial conditions, and then things happen, and maybe there can be a statistical fluctuation that's far in one direction or not, or maybe like there's a chaotic push that sends you in some place. To what extent that's by choice, I think is just really complicated.
Yeah, but I don't know that I need it to be by choice. I think I just need it to be worthwhile. Like I need it to be good enough to justify being here, I guess.
Right.
To justify hanging around, if that makes sense. I don't need it to be fair. I know that it's deeply unfair. In addition to being unjust, it's unfair, right? Like it's obviously unjust, like human-created systems and structures have created tremendous injustice, but there's also just unfairness. There's also the randomness of unfairness. Like you can get cancer when you're 10 years old and you didn't do anything to make that happen, and nobody did.
Yeah. Yeah.
But I need life to be beautiful enough, like the universe. Because I think in what I ultimately, if I zoom all the way out, it's not just that I'm seeking understanding, although I am. I'm seeking understanding and beauty. And I'm seeking the beauty because I want to know that there is enough beauty in the universe and in a human life for it to be worth it. Like, I know that the universe doesn't think of itself as worth it or not worth it. I know that's not how the universe thinks of things, but that's how I have to think of things. And so I need the universe to be beautiful enough that it's worth it, that it's worth seeking that understanding, that it's worth trying to, overcome all of the challenges and all of the things that we can't know to understand what we can know.
Yeah, and I think there is, as we said before, I think there is tremendous beauty in the universe, and there can be tremendous beauty in a life. I mean, even if you have some vague notion of like what the broad strokes outline of it is, like the details are fascinating, right? Like the different places you can go within whatever constraints are sort of built in, or whichever path you've been kind of pushed toward through your circumstances. Like you can always find those incredible little statistical fluctuations of fascinating, beautiful things. And you just have to kind of look around and explore that parameter space and just kind of to see where things branch off into something really, really interesting. I think that's part of what makes life amazing and worth living is finding those little branching points and finding where things get a little bit weird or a little bit different or counterintuitive or surprising, and chasing that.
Yeah. Could we call it the pursuit of understanding guided by beauty? Or is that too far of a bridge? It's too far of a bridge for you, I can already tell.
No, I think for
the pursuit of understanding, maybe beauty is the wrong word, guided by that surprise or that wonder, guided by wonder, maybe.
Yeah. And I mean, what makes me hesitate there is I think you're talking in terms of just human existence.
Yeah. Like what we should be doing.
Right. But I think even as scientists, I think there's an extent to which we're doing that, right? Like we're trying to understand, but we also crave that novelty, that surprise. When physicists get together, like, let's say they're at a conference or, people are meeting for coffee or something, or, somebody's visiting the department, they ask each other, like, what are you working on? But the way that it's phrased is sometimes it's, what are you working on? Sometimes it's like, what are you excited about? And it's always this, like, kind of like, tell me something cool and interesting and weird, right? And that's where those conversations go. Like, everybody wants to know, like, what's exciting to you right now? What's surprising? What's interesting? What's the thing that gets you, I don't know, most interested, most excited, most invested? And it's always the stuff that's like, maybe this is surprising. Maybe this is astonishing. Maybe this is something that was unexpected. Like, that's the stuff that's really fun. And that's what we all kind of crave when we're doing this stuff.
Yeah, that's interesting. I think that's a fundamental misunderstanding between the public sometimes and science.
Yeah.
Which is that you're looking for the places where you're surprised. You're looking for the places where received information was wrong.
Yeah.
And you're looking for the places where, like, science can be refined. And a lot of times when people talk about science in sort of more public spaces, they talk about it as this monolithic thing that is either right or wrong.
Right.
As opposed to something that is trying to get better and is actually excited about being wrong, because that means that there's a possibility of learning something new.
Yeah, I mean, I hear a lot of people complaining about, the scientific establishment and, how all of these gatekeepers are, suppressing the maverick visionaries and stuff like that. And if you actually, like, hang out with physicists, like, everybody's trying to be the maverick visionary at some level. Like, we're all trying to do that, right? Like, that's like, I was just this morning when I was getting my tea, I overheard two people talking, and one was talking about his new model for something, and he was like, "Oh yeah, it's quite audacious." It's like, and like,
right,
like, yeah, like, that's what we want. Right?
We want to be audacious. Yeah, it's exciting to be audacious.
Yeah. There is that day-to-day work that we're trying to do, but the hope is always that you're going to find something unexpected in that data, right? Like, that's why when the Large Hadron Collider found the Higgs boson but has not found other new particles, like, that's why people are upset that we haven't found other new particles just besides the Higgs boson. There's been a lot of really important work with the Large Hadron Collider, and it's helping us to refine a bunch of theories, and we're getting a lot of really important data from it. But all the physicists, when we talk about the idea that the Large Hadron Collider finds the Higgs boson, which was predicted, and nothing else, we call it the nightmare scenario, right? Like, we really want something new, right? Like, we really want to see, and that's partially because we do like novelty, but it's also because that's how we make better theories. Is that if you start out with, like, Newton's laws of gravitation, right? Like, and then you try to apply that to the motion of Mercury around the sun or how things move around black holes, it doesn't work. It breaks in those contexts. And that's how we find general relativity. Like, that's how you get to that new model. And that new model is valid in a larger set of circumstances. Doesn't mean that the old model's wrong. Like, you still use Newton's laws to calculate how a ball rolls down a hill. You could use Einstein's equations for that, but it would be a disaster. Like, you would really ruin your day. So you use Newton's laws because on that level, they're as accurate within your measurements as the more sort of complete theory. But it wasn't until you found those places where Newton's theory breaks that you were able to advance to general relativity, to this sort of broader theory that's valid in more circumstances. And so we're always trying to find where our current theories break. And some of that is, like, by doing more and more precise measurements, you can find that stuff. Sometimes by doing measurements in other contexts, in, like, different kinds of experiments, by getting data from more extreme astrophysical environments, for example. So we're always trying to break stuff. Right? Like, we always want to break what our current model is so that we can make a better model that's more expansive or valid in more circumstances. But, like, nobody sets out in their career to be like, I'm just going to uphold the status quo.
Right.
I'm going to prove that we're right all along.
I think that's true for all kinds of inquiry. I think that's true for creative expression. I think nobody sets out to say, I'm going to uphold the status quo of poetry or young adult literature or whatever. It's true of all kinds of inquiry. So we have to include that as well in our reasons for why life might be worth it. But I really like this idea of seeking surprise and wonder alongside seeking understanding.
Yeah.
I think you're right that it's not just about understanding. It's also about the meaning making and the puzzle solving and the doing Wordle. Like that's all. It's all interconnected for me in what we're doing here, in the broadest sense.
Yeah, I think, there's a set of things that humans as animals really enjoy, right? And some of those things involve like just figuring stuff out. Like we just really enjoy figuring stuff out. We also enjoy art and music and other things that are beautiful. And I think that a lot of those things kind of fit together. And some of it has to do with surprise. Some of the things that are beautiful about art and music have to do with surprise, with things that are unexpected that come up and like, oh, what is that? I think that all kind of fits together. We like that novelty. We also like things that fit together beautifully and perfectly. We like, sort of satisfying symmetries and that kind of stuff.
Right. Yeah, we like the moment where things click together.
Yeah.
I mean, that's what my favorite part of writing is there's always or not always, if I'm very lucky, there's a moment where I start to feel things click together. And that high of things clicking together, whether it's plot-wise or character-wise or whatever, is what I'm chasing the whole time.
Right. Yeah, and so I think it's a little bit that balance of like the novelty versus the coherence, right? And also in science, I should say, like, although we are all trying to like break stuff and find new things, there's a limit to like if somebody comes in and just has a totally outlandish theory that has nothing to do with what our current understanding is, we're not going to automatically be like, yes, that's awesome, right? like there is some level of conservatism in terms of like, we don't want to get too excited about something that doesn't have backing in evidence. We have to evaluate, we have to be skeptical to some degree. But if something can prove itself to be useful, to be valid, and is surprising, like that's awesome, right? So things that are sort of confined in the structure that we have that also have that novelty. I think that's, it's like how there are sort of these structures of poems, right? Like you can write a haiku or a sonnet or whatever, and there's a very clear structure around it, but you can still do surprising things inside that structure. So we kind of like both the sort of coherent structure of something and that little bit of surprise, that little bit of novelty or something that's just like satisfyingly different or new, while also sort of satisfyingly cohering to the whole.
Yeah.
I guess
you're working within a genre, like mystery novels or whatever, or YA fiction, or the sonnet. You're using the form and structure, but you still want there to be wonder and surprise and newness within that.
Exactly. Yeah.
Well, I feel like we've successfully merged art and astronomy.
Excellent.
I feel like I don't want to overstate it, but found a purpose for me to go on living.
Okay. I'm really glad about that. Good.
So that's good.
Yes.
But I really do, though, like in the sense that if I can stay connected to that idea that, I mean, both the loveliness of I'm sure it's frustrating for you at times, but from my perspective, the loveliness of quantum uncertainty and chaos, and this idea that we're here, at least in part, to understand and have that understanding guided by wonder and newness and excitement. That really does kind of put my feet on the ground about what I'm supposed to be doing, or what I'm supposed to, like, what feelings and experiences and lines of inquiry are really worth chasing. So, thanks.
Yeah, you're welcome. It's fun to think about how all this stuff fits into like human nature, because you can't entirely disconnect science from humans, right? Like we are doing this, we are bringing in all of our biases, all of our weird little evolutionary quirks. Like this all comes into how we do science. I think in the best circumstances, it works out well. in the worst circumstances, something, terrible things can happen. But I think that there is a wonderful system in which we can use our sort of animal proclivities toward novelty and the satisfaction of coherent structure and use that to our advantage to understand the universe better in a scientific way. And I love that we can do that.
Yeah, it reminds me of something a friend told me once, which is that every book was written by a mammal. It's really, really easy to forget that.
Right.
But all books are written by mammals. All science is done by mammals.
Exactly. Yeah.
And we need to remember that we're mammals. That's a weird situation to be in, to be like a mammal that also knows what the first few picoseconds of the universe looked like.
Right. Yeah. How did we even... What?
If you gave raccoons that power, they would also be freaked out.
Yeah. It feels wrong that we're allowed to do this, but I'm glad that we are.
Me too. I'm glad that our ancestors crawled out of the oceans and allowed this to become possible. Yeah. And I'm also glad to know that it's not quite as inevitable as I presumed it to be after the first few episodes of this podcast. Katie has certainly left me with some things to think about, and I can't thank her enough for answering all my questions. Now, we've come a very long way in our journey through the timeline of the universe, but we aren't done yet, because we still have the future to encounter. Next time, Katie will explain to us what the future of the universe looks like, and I imagine it will raise more questions along the way. Thanks for listening to Crash Course the Universe, which is hosted by me, John Green, and Dr. Katie Mack. This episode was produced by Hannah West, edited by Linus Obenhaus, with music and mix by Joseph Tuna-Medish. Special thanks to the Perimeter Institute for Theoretical Physics. Our associate script editor is Annie Fillenworth. Our editorial directors are Dr. Darcy Shapiro and Megan Modafferi, and our executive producers are Heather DiDiego and Seth Radley. This show is a production of Complexly. If you want to help keep Crash Course free for everyone forever, you can join our community on Patreon at patreon.com/crashcourse.